In this video, we're going to talk about two of the four foundational technologies inside Bitcoin, cryptography and proof of work. Let's start with cryptography. Cryptography is a method of disguising and revealing information using complex mathematics. It's used every time you log into an account using a password. It's based on a mathematic principle where it's easy to calculate forwards, but difficult to calculate backwards. For example, it's easy to find out that 19 times 31 is 512. But how long would it take you to go backwards and find out 512 was multiplied by those two prime numbers perfectly? Imagine this math problem, but hundreds of digits long. The only way to figure this out is by trial and error, which, even for the world's fastest computers, could take years to solve. That's a simplified explanation of how cryptography works. The data in Bitcoin is run through a cryptographic function called a hashing algorithm. Bitcoin uses a popular and well-tested hashing algorithm called SHA-256. Here's an example of what it looks like. A hash is a 64-character jumble of numbers and letters generated after running your data through the hashing algorithm. No matter what size of text you put in, the hash will always return 64 characters. One small change and the hash changes completely. It's designed so that it would take a lot of computing power to go back and find or guess the correct equation that generated that hash. This is essentially what the third foundational technology, proof of work, is based upon, guessing. The term Bitcoin mining relates directly to computers guessing or attempting to solve the math problem presented by a special hash generated by the SHA-256 algorithm. If a computer is able to solve the problem, that's proof of work that was completed. This is what a Bitcoin miner looks like, but under the hood, it's a mathematical lottery, and whichever computer guesses the correct solution wins. The winning miner gets to write to the blockchain, assembling a set of transactions into a block, which is called a confirmation. As a reward for confirming, the miner gets newly created Bitcoin and collects fees off each transaction in the block. The Bitcoin rewards provide monetary incentive for miners. Depending on the price of Bitcoin and the cost of equipment and electricity, Bitcoin mining can be very profitable. If you'd like to do it the cheap way, there's an example of someone doing this by pencil and paper, but this is really inefficient as mining hardware is a quintillion times faster. That's 18 zeros. To give you a better idea of the difficulty in this math problem, think of it this way. A single miner could take years to solve this problem, but thousands of computers around the world working on it at the same time could solve it much faster. The Bitcoin network automatically adjusts so that at least one computer can find a block in 10 minutes on average, and can even account for newer, faster hardware being developed. Here's the key idea though. There are thousands of miners, all with an equal chance to solve the math problem and win the right to confirm a block onto the blockchain. For an attacker that would love to write its own data to the blockchain in order to steal money, which computer do they choose to attack? This is what protects Bitcoin. The only way to attack the network is by gaining control of over half of the worldwide computing power, also known as hash rate. This is called a 51% attack. In the lottery analogy, it's like owning over half the ballots, all but guaranteeing that you win the lottery multiple times in a row. Proof of work makes this kind of attack very expensive. In fact, there's a website that tells you how much it costs in electricity to attack the network, not even including the expensive computers. You can see that Bitcoin is much more expensive to attack when compared to the other altcoins. As the world's most popular cryptocurrency, Bitcoin has a lot more participants in the network, meaning a lot more miners to compete with, making it more expensive to attack. In the blockchain governance model, miners build on the longest chain. So, for example, if you're trying to change your wallet balance in block 38 and it's currently block 41, you need to remine confirmed blocks 39, 40, 41, and successfully mine block 42 faster than the rest of the network. The more time passes, the more times you need to win the lottery to catch up, and the more energy and money you need to spend. Ultimately, the cost of attack outweighs the potential reward. This connects with the term confirmations, a common word used in Bitcoin wallets and block explorers. Each time a block is solved, it's counted as a confirmation. Tying into the previous example, if this transaction was in block 38 and it's already 4 confirmations, the attacker would need to solve the block 4 times in order to catch up to the longest chain and replace it. The amount of confirmations essentially shows how expensive it would be to change a transaction. All that security comes at a price, and the price is energy. You may have heard proof of work caused by Bitcoin mining consumes a lot of electricity, and Bitcoin has been criticized for being harmful to the planet. Studies show, however, that much of Bitcoin's electricity comes from renewable, clean sources, and it's been argued that it's actually better for the environment than our legacy money systems. Since the cost of mining is based on how expensive energy is, mining ends up happening in places where energy is cheap, and that tends to be where energy is renewable. Also, mining is occurring in places without the infrastructure or demand to monetize electricity, like remote parts of China. It's easy to point the finger at Bitcoin because the entire system is transparent and energy costs are easy to quantify. In our traditional money system, all the energy and other environmental costs are hidden. Trees are cut for paper bills, oil is drilled for plastic, trucks burn diesel moving cash, brick and mortar banks need AC, heat, and lights, all the mining for metal, and all the infrastructure for intermediaries. There's a lot to consider. In summary, Bitcoin uses complex cryptography that can only be broken by guessing, requiring a massive amount of computing power. Remember that one computer takes years to solve the math problem, but with thousands of computers working at the same time, it takes 10 minutes on average. The requirement for proof of work makes it too expensive and infeasible for attackers. Attackers don't know which computer to attack, and the amount of money they need to spend to attack the network is way too high to justify the reward. At this point, you've learned blockchain, cryptography, and proof of work. The fourth and final technology used in Bitcoin is its peer-to-peer network. Go to part 3 where we tell you how it all works together.